So guys, let's do some breakdown of the 10 billion naira allocated for the installation of mini grid for the Aso Rock. Now we are going to start from fact, then do the remaining video based on assumption. Now, on the aspect of facts, according to Intel region, as of 2024, Tinubu government spent about 483.3 million naira on electricity. Approximately, that is 484 million naira. We will do a calculation to end up with the amount of energy they consume per day. So if they spend 484 million naira in 365 days, we divide that by 365. It means in one day, Tinubu government spent about 1,326,000. That is in one day, which is 24 hours. Now, if you divide that, it means Tinubu government in 1 hour as of 2024 spent about 55,250 naira per hour. If you are in band a kilowatt of energy costs about 225 naira. Now, for us to get the amount of energy Tinubu government consumed per hour as of 2024, we are going to divide 55,250 naira by 225 naira because a kilowatt is 225 naira. So 55,250 naira divided by 225 naira will give us 246 kilowatt hour approximately. So Tinubu government as of 2024 was consuming, or we are consuming, 246 kilowatt per hour. So if you multiply 246 kilowatt per hour, that will give you about 55,200 and something naira. That was what they spent per hour. Now, it means Tinubu government do consume 246 kilowatts per hour. After knowing the amount of energy they consume per hour, we will design a system suitable for them. This is Aso Rock and we wouldn't want the lights to go off. So we'll consider 24 hours or 32 hours of autonomy. It means the day that there won't be sunlight and his appliances or the appliances in Aso Rock will depend on the battery bank. So let's use 32 hours of autonomy. Now, if they consume 246,000 watts per hour, we'll consider 32 hours of autonomy. We'll multiply 246,000 by 32, which will give us 7,872 kilowatts, approximately 7.9 megawatts. That is the amount of energy they will need to sustain them for 32 hours if there is no sunlight. The inverter that will be needed for this system will be 350 kilowatts, since their load consumption is about 246 kilowatts. So a 350 kilowatt inverter should do the job very well without a problem. The last thing we include for them in this system is the number of panels. Since they are going off grid, they will not be depending on the national grid. They will only be depending on solar panels, then maybe their mechanogen or their generators. We'll give them enough panels so that the battery will charge very fast, even in a dull weather or on rainy days. So to get this battery bank filled within 4 to 5 hours, we'll allocate 3,500 units of 665 watt solar panels to this battery bank. Though the solar panels are oversized, but the reason is in case of rainy days, they might drain out the batteries completely, and the next day the battery will start charging from 0%. So in a day, if there is sunlight, they will be depending on the solar panels. Let's assume they consume about 2.5 megawatt from this battery bank, which is 10 megawatt. They consume about 2.5 megawatt overnight. The next morning, it will take the battery just about 1 hour plus to get the battery filled back to 100%. So this is a good design to cover for them. Now, let's look at how much it will cost for them to set up this system. If they are going with a 10 megawatt battery bank, a 10 megawatt battery bank will cost about 4,920 million naira, which is 4.9 billion naira approximately. Then if they are going with a 350 kilowatt inverter, a 350 kilowatt inverter will cost about 16.4 million naira. Now remember, the number of panels they are supposed to use will be about 3,500 units of 665 watts, and that will cost about 612,500,000. Now the accessories that will be okay for this installation, that will cover for the cables, the breakers, the protective devices, might cost around 900 million naira. It might not be up to this, an approximate, this is an assumption, right? So let's say service charge, because the batteries will come in containers, like 3 containers or even 4 containers, so the transportation might be high. With the service charge, let's say they will charge about 1 billion naira. So in total, they might spend about 7.4 billion naira for them to set up a system. So with 7.4 billion naira, they will be able to set up 10 megawatt hour lithium battery, 2.3 megawatt solar panels, and a 350 kilowatt inverter, which will be okay for them. But if they will not consider days of autonomy, either 24 hours of autonomy or 32 hours of autonomy, it means they are going to spend less. Maybe they will end up spending 4 point something billion naira or highest 5 point something billion naira. So don't forget to drop your comments by telling us what they will do with the remaining change.